Hello, so let's start with today daily problem. Leetcode 1630. Arithmetic sub arrays. So in this question, a sequence of number is called arithmetic if it is consist of at least two elements and the difference between every two consecutive element is same. So that's the definition of typical AP series. That's mean if you are having suppose you are having three elements. If you are having three elements x1, x2 and x3, so difference between consecutive element should be same. That's mean x1 minus x2 will be equal to x2 minus x3. Here should be x3. So that's the definition of typical AP series. So that's given here. So difference of any consecutive two elements should be the same, and it should follow for the all the element of the that subarray. So the main question is, for example, this is the subarray and yeah. So the question is, you are given a array of n integer nums and two array of m integer l and r. So after that array they will give you two more integer, and ith element of left integer will denote the starting point of the subarray, and r point of the ith element will represent the end point of the subarray. That means if you are having some subarray, so there will be two array, one is l and one is r. So first point of L and first point of R. So first of point of L will represent the starting point of the original array. Suppose this one the original array A, that is given in nums, that is given in the question. So ith point, suppose ith point of the L element and ith point of the R element represent the starting point of the subarray and end point of the subarray. So that is given, and return the boolean element answer where answer I is true if the subarray num I and subarray starting from the li and ending till the ri, if you can arrange that subarray in AP. That's mean suppose you are having a array, and in each query you will get starting point of the array and ending point of the array. And if you make a AP using all the element of that subarray, if you are having five element in this in between, so if you make a AP using this subarray, then you have to return one for that query. And if you can't make if you can't arrange those element in AP, then you have to return 0. That's the main question. And there are m such query we are having. So for each query we have to check in the that particular subarray, and if that particular subarray can rearrange in AP, then we have to return 1, otherwise 0. So the thing is how to query each array, each subquery. So if you want to, if you will rearrange the original one, original subarray, then when next time we will get the subarray, when we want to next time get the element of that subarray, then you will not get the original one. That means suppose we are having one example. Suppose we are having subarray 1, 1, 2, and 3, and then we are having suppose 4 and 5. So if you rearrange this one, suppose in first query you got this subarray, and if you rearrange this one in somehow, and after in next query if you get the this part, then if you make a rearrangement in this original one, then when next time you will try to access the all the element of this subarray, you will not get the original subarray. After that one, maybe you will place 5 here or something else. Depends on the what are the elements is in previous subarray. So you will not change. We should not change the original element. For that, for each query, you have to make a copy of the original element of that subarray, and you have to perform operation on that copy points. So the time taken by the copy one will take order of n, because it may be starting from the first position and ending to the end position. So this is the idea. You first make a copy of that subarray and then perform operation and check is it is possible to arrange them in sequencing in increasing or decreasing array to make a AP or GP. If yes, then return 1, otherwise return 0. So let's take a look on constraint. So constraint is pretty good because n is of length 500 only, and m is also 500. So we can easily perform n into m operation. So for each query, uh, it will take m operation, n operation, and we are having such m query. So let's set, let's go on the coding section. So the approach is first make a copy of that subarray starting from the left point and ending from the right point, and we are adding one extra here because uh, last index of this last index is not inclusive, it's exclusive. So that's why, and we want to include that one, so you have to put extra one here. And after sort the element and check for each consecutive element, if difference between previous consecutive element is not equal to difference of a next consecutive element, that means it is not in AP. So push the loop and put 0 for that. And if all the all the consecutive element, if this relation hold, AP relation hold, that means it is in AP, and put 1 here. So uh, and time complexity of this one will be for making copy order of n and sorting n log n, and here we are having m such queries, so time complexity will be n cross n log n. Thank you.